In this specific video, you are going to understand about encoders and the examples for encoders as octal to binary encoder and priority encoders. And first we understood what is an encoder. So encoder which converts one form of code into another form of code, which is the inverse process of a decoder. Already we have seen in other videos about the decoders. If you have not seen that, you visit that videos to understand what is the decoding operation. So encoding is a just reverse process. That is, again, it is going to convert the the converted form of code back into the original form of coding. So it also has a certain combination relation between the output and input. So it can have 2 power n combination of inputs for the maximum 2. It can generate n unique output lines. So if you are having 2 power n combination of inputs, it can generate n output lines. So the general structure of an encoder will looks like this. There will be a 2 power n combination of inputs and it will generate n possible outputs. And to activate the outputs, we'll be having enable inputs. If enable input is active, then only for the given input combination will be accepted and output will be generated as a valid one, else the outputs are invalid. So it has 2 power n input lines and only one is active at any time and n output lines. That is, out of 2 power n input combinations, it is assumed that only one to be high level. You cannot have more than one input as high level. So that is the thing available, constraint in the encoders. So in such scenario only it will be validated. So you can have the question that if there is more than one input comes as high level, so that we'll be discussing in the next topic as the priority encoder. Now look at the encoder. So the constraint is only one input is high level at any instant. And for this we can have an example as octal to binary encoder. So you have an octal number. So for the octal number, we will be getting binary numbers as output. Look at the octal numbers. You have which is going to be the active high. You have 8 combination of input. So from this 8 combination, any one of the thing is high level at any instant. So look at the input column D0 to D7, only one is high level at any instant. And look at the output, we have 3 outputs. So 2 power 3 inputs are there, that is 8 is equal to 2 power 3. So 2 power 3 inputs are there, so 3 outputs we can achieve. So from this table, we can get the expression for Z and Y and X. Z is high level during D1, D3, D5 or D7. Like that, we got the expression for X, Y, Z. So we can draw the logical circuit with the help of OR gate, simply OR gate. So for this combination, we'll get the output as like this. So that is sometimes all the thing is going to be 0. So this is same as when D0 is equal to 1. So to resolve this, at least one input is equal to 1. So that's what D0 becomes. It's made as 1. So in the while talking about the decoder, we have mentioned that the encoder, each input in the encoder must have only one should have the high level at any instant. So if more than one input becomes a high level, so to convert that encoder, we'll be going for the priority encoder. So the priority encoder is, it assigns each, for each line it will be assigning a priority. So if both the things, both inputs are high level, then which line is having the priority, that is going to be converted. So to determine the priority, which line is having, we will be designing this circuit. So look at this. So D0, D1, D2, D3. So here, the, look at this. D3 has the highest priority, and D2 has the next priority level. So when D3 is 0, as long as D3 is 0, depending on D0, D1, D2 values, the output will be the response. When D3 goes to 1, only it is going to be activated, and irrespective of D2, D1 and D0. In the output column, V is given, it is to make the valid outputs. If V becomes 0, nothing is going to be valid. So when D3 becomes 0 and D2 is also 0 and D1 is also 0, by the time only D0 will get chance. Or otherwise, when D3 is 0 and D2 is 1, then D1, D0 cannot be considered. So this is the priority levels. So to design the circuit for that, we need to go for X, Y. So the XY will be derived over there, and V is going to represent the valid input, output. So X, Y and V expression we get X and Y from the K-map, and V directly we are getting it. So this is the priority encoder. Out of the 4 inputs, when D3 comes, irrespective of D2, D1, D0, it is going to be activated. So this is the priority encoder. So the student, in this video, we discussed about the encoder. One example as octal to binary encoder and priority encoder. Thank you, students. This is Professor Ilangovan signing off. Bye bye. Thank you.